Hey, you made it back. So we just got done graphing this hyperbola. What I want to do is start taking it a little bit further and find some of these key features. So with this same exact hyperbola that we just made, the next question is going to be find the foci. Where's the focal points for this thing? We can look at it and kind of eyeball it and say, well, it doesn't make sense for them to be this way. They're going to be inside these almost parabolic looking shapes where these two friends are that were when we did our little friend analogy. So it's going to be somewhere in here. Notice I'm going to start from my center, and I'm going to change the x-coordinate to get to 1, and change the x-coordinate the other way to get to the other. So the y-coordinate stays the same, k. K is the same for this. H is the one that's changing. So for any side-opening hyperbola, we can think of it this way. We can say, well, I'm going to start from the center, and then I'm going to go left and right, c units. Remember we had our A, B, and C. The y-coordinate of the center, that's not changing. So we're changing the x-coordinate, y-coordinate stays the same. If it was a top opening hyperbola, x-coordinate's not changing, y-coordinate is changing. Silence my phone. I got a feeling that's going to happen a few times during this hiatus. Okay, so the next part is the C thing. Well, what is C? Now remember, for an ellipse, it was the non-Pythagorean theorem, but for a hyperbola, it's just the Pythagorean theorem. A squared plus B squared equals C squared. Then we can solve for C there because we have A squared. A squared always comes first for a hyperbola, and B squared. So I can just jam those in there and say A squared plus B squared equals C squared. Okay. C would be plus or minus the square root of 13. That's how many units I'm going to go over to where my center is. And then I'm going to go right square root of 13 units this way. And I'm going to go left square root of 13 units this way. And that'll put me at my two focal points. We can write it like this if we want to be exact. Go from your H value and go left and right square root of 13. Y value staying the same. Or if we wanted to approximate, we could just jam that in our calculator. Okay, so we're dancing now. We're getting some key features of a hyperbola. The next key feature for a hyperbola that I would like to mention are those slant asymptotes we talked about. Like drawing them is not a big deal. Drawing them is just a matter of making that little rectangle that we talked about, going up and down, some units left and right, some units, and then drawing the diagonals. But algebraically speaking, this is how we find the equations of those lines. Think y equals mx plus b. We kind of do have our y equals mx and then plus b kind of in there. But for a top opening hyperbola, it's a over b. We have those values. For a side opening hyperbola, it's b over a. We'll have those values. Okay, and then it's just a matter of plugging those in and cleaning stuff up. H and K is the center. Okay, so let's try this problem. Take a minute if you want. Why don't you hit pause, try it on your own, see how far you get, see where you get stuck, and then we'll come back and hit play and we'll finish it up. Okay, we're back. Write the equation of the hyperbola with vertices 5, 1 and 5, negative 5 that has slant asymptotes, this kind of mess. First thing I like to do is kind of draw myself a picture. If I know the vertices are 5, 1 and 5, negative 5, halfway between those is going to be the center. So we have a lot of information. Just by telling me that these are two vertices, we can get this. Halfway between 5, 1 and 5, negative 5 is 5, negative 2. Midpoint, right? Just add them and divide by 2. That would be my H and my K. We even have another piece of information here. The distance that you have to travel to get from the center to a vertex, to one of the vertices, that's what we define that to be A in our little formula. So we know how far apart those are. That's 3. 1, 2, 3. To get from 1 to negative 2, from negative 2 to negative 5. Those are 3 units. So just with that little bit of piece of information, we can fill out a lot. Because it's a top opening hyperbola, notice it's top. If these are my vertices, the vertices are over top of each other vertically, then the hyperbola is going to have to open up and down. So we have the y coming first. Ooh, and I already found a typo, but I'm just going to roll with the typo. That's how we're going to do this. Maybe you found the typo as well, but it's not supposed to be that. It's got to be a minus sign if it's a hyperbola, Mr. Edwards. So change that to a minus sign now. Okay. We have our H and our K. There's H. There's K with a little bit of sign flip equal to 1 in standard form. We're almost done. The last thing we need to just figure out now is what is A squared and what is B squared. Remember, on a hyperbola, the A squared one always comes first, where it was flip-flopping a little bit for us on ellipses. A squared will always come first. So we talked about this a second ago. The definition of A in a hyperbola is how far you have to travel to get from the center to one of the vertices. So A is 3. can do that right now. If a is 3, a squared would be 9. That's what goes underneath this thing. So it's y minus k squared over a squared minus x minus h squared over b squared. Well, we have a squared. A squared is 9. Awesome. So we're down to one variable. There's only one thing we still need to find. And some of you may have spotted a shortcut here. And kudos if you did. If not, it's okay to attack these things in different ways. So this is what we're sitting at. H, K, A. The only other thing we need is B. Okay, well, I gave you the slant asymptote. The other piece of information I gave you was a slant asymptote. And remember, for a top opening hyperbola, this was what the equation of our slant asymptote should be. So we have our H and K. We have our A, and we already found that actually. This is the shortcut I was talking about. A is 3. Well, that means that B has to be root 6. It's given to me in my problem. If I know how this thing is set up, the slope, if you will, of this line. Ooh, I don't like the squares too. Man, I might redo this. Oh, I'm not going to redo it. We're just going. There's no squares in there. It's not a quadratic. Silly, Mr. Edwards. Hopefully you didn't write that down. Okay. But either way, A is still 3. B is root 6. If B is root 6, then B squared, that's what this question mark is. B squared is just 6. So we put a 6 in there. We have our equation of our hyperbola, and that's it. Okay. I picked out some problems for you guys to try on your own. It's a stamp, but I can't go through and check the stamp, so the responsibility is on you. The onus is on you to go through and try these things. But here are some problems I think would be beneficial for you to attack and go over. I gave you a lot of odds, all odds in fact, so check the back of the book, and then if there are some you don't know how to do, or you're not sure, email me. Show up to an office hour, something like that, and we have some hyperbolas. We have some hyperbola knowledge now to be working with. So end the second video. I will see you guys on the flip.